Hello students of the HPC tool subject in the Master in HPC. This short video is just to explain you the second important feature of the Intel Inspector tool of the Parallel Studio suite. In this case, we are going to use this tool to debug memory threading errors. So in a previous video, I showed you how to use Inspector also, but to debug memory errors. And now, in this case, we are going to focus on the behavior of threadings. When we talk about this from a theoretical point of view, we mention a number of problems that can be detected by this tool, like, for instance, deadlocks or race conditions. In order to make this tutorial, we need to use the same code that in the previous video, that is the tachyon code, that is a ray tracing application. So we have already the code. Remember that you have to disable the debugging here, because if not, it's not going to work correctly. Okay, so we are going to use the threading building blocks library without debugging, and then we can clean the code and compile it. Okay, so this is going to generate 3 binaries again, and in this case we are going to focus on this one, tachyon, find and fix threading errors. So I have to start Inspector, and in order to do this, I have to source the file opt Intel Inspector inspxe bars.sh. Okay, and then don't forget to set the editor of your choice as an environment variable. In my case, I use Microsoft Visual Code. Okay, once this is done, I have to start Inspector. Okay, so this is started, and then I have to start a new project for this application. That is going to be the thread, for instance, the name. Okay, create project, and then I have to select the binary of the application. So the binary is in descargas, in my case, downloads in Spanish, tachyon inspector, find and fix threading errors. It doesn't require parameters like in the previous video, and then I press OK, and I create a new analysis. And in this case, the analysis, instead of being the memory error analysis, is going to be the threading error analysis, and the layout of the configuration of the analysis is very similar to the case of the memory error analysis. So, for instance, here we can detect the level of detail of the detection. Instead of the default value, we are going to allow to Inspector to detect not just deadlocks, but also data races. And all the other options can be left by default. So, once it's configured, I have to start the analysis. It doesn't take too much time, so you can see that the rendering of the model is not good, because there are some errors in the rendering, and that's associated to the problem that is going to be detected. So now it's collecting the data. It's taking some time, because you know that have to generate the result to be visualized, and then you can see that there are a couple of data races errors. Like it happened before, in order to go to each error, you have to double click the error, and in this case you see that there is a race condition in the writing of the call value. This is the error that is causing the malfunctioning. Okay, so the problem is that this variable is global, is declared here, so all the threads are going to share the same variable, and depending on which one writes the call variable in the first place, is going to change the result of the computation, and that's the cause of the errors. And this is a typical scenario where we have a race condition. So we have two ways to resolve this. So instead of having a global declaration of call, let's have a local declaration of call. Okay, so in order to do this, we open the code. It's opening correctly because I have set up correctly the editor environment variable. And then now I have to comment this declaration, and then I put it here. This is going to declare a different local variable for each thread. So this column variable is going to be local to each thread, and the race condition is not going to happen anymore. A second way to do it is to leave the declaration as it was before, but putting logs around this area of the code in order to avoid that several threads are concurrently writing the value of this variable. But that will be clearly inefficient. This solution, to declare it locally instead of globally, is going to be the best performing solution of both. Okay, so now we can save the changes, and we close the code, and then we can go to the next error. We double click, and we see that the problem is that this application has one statistic in order to count how many updates are happening per time unit. This is not a very bad error because it's just for statistics purpose, so maybe there is a slight variation due to the race condition, but this is not very important. So this solution with the race condition is causing a data race, but this is not causing a malfunctioning of the application itself. It's just changing a little bit the value obtained in the statistics because several threads are updating this counter at the same time, but this is not a big deal. So in order to keep it efficient, we can leave it that way. So in summary, this is an error that we don't have to try to solve. Okay, so that's it. I think that the code should work much better now, and we can check it just recompiling the code, make clean, and then make again. And now we go again to the project, create a new analysis. The analysis is by default now configured as we want it to be, and now we can start again, and we should see is that now, as you can see, the application is rendering perfectly the model without any error. That's a symptom that we have solved our threading errors and the race condition that was causing the malfunctioning. Okay, so let's check what happens in the summary of the results. Okay, so now the first race condition is removed, and only this one that we choose to keep is still there, but we said that this is not cause any kind of malfunctioning in the program, just is going to change slightly the statistics gathered or collected by the code. Okay, so that's it from my side. This is just an example of the kind of threading errors that can be detected by this tool, Intel Inspector. Okay, so see you in the next video of HP.